Assalamualaikum. This is our group project for the subject MAT575 for the topic least square method.
Let me introduce our team members. Me, Raja Nur Atira binti Raja Muhammad Farid, and my partner is Siti Nur Farisha binti Ruslan.
Our description of work. One of the core components of research in plant biology, botany, and ecology is the study of measurement of leaf circumference. It can offer insightful information about the development, well-being, and ecological trends of plants. Data of leaf circumference can shed light on how plant groups function ecologically, how they adapt to their surroundings, and how they deal with climate change. Leaf circumference is a useful tool in agriculture for determining plant biomass, which is important for determining crop productivity and health.
Next, I'll continue with our problem statement. Least square method usually used in the most of the problem in our daily life. In our case, we want to identify an arc length of the leaf from the x and y axis that obtained from the coordinates point of the leaves. Arc lengths refer to the distance between 2 points along a curved section. The least square method is one of the solutions to find the best fit for a set of data points. The method works by minimizing the sum of the offset or residuals of points from the plotted curve.
This is the data set of leaf, which is X stand for x-axis and Y stand for y-axis. Alright, this is our leaf. This is the graph of leaf that we draw on a graph paper. As you can see here, there are 4 parts of the function from that leaf. We label it as a first function, second function, third function, and fourth function.
Next, I'll continue with the solution part. In the previous slides, there are about 12 pairs of coordinates points of the leaves. To make it easier, we divide it into several parts to make it more accurate equations of the curve. For the first equation, we take about 4 pairs of coordinate points. We use the least square method and construct the tables as shown in the slide. We find out the summation of x, y, x squared, x cubed, x power of 4, xy, and the last one is x squared y. Moving on. This is basically our formula for the least square method. They are in the forms of matrix and it's a total number of pairs of the coordinates point used. Next, we substitute the value that have been calculated according to the formula that I've been go through just now. To find out the value of A0, A1 and A2 is by using simultaneous equation by using calculator. Therefore, we get our first equations of the curve. Moving on. We will continue with another 4 points of the pairs of the coordinate to find out our second equations of the curve. We use the same method as before. We find out the summations value of x, y squared, x cubed, x power of 4, xy, and x squared y. Therefore, our second equation is 12.2864 minus 1.5065x plus 0.0724x squared. Alright, next, we still use the same steps as before to get the third equations of the curve by using other next pairs of coordinates of the points. So, this is our third equations of the curve. So basically, we go through with the same method until complete all the pairs of coordinates of the points that we have been stated from our data set. So this is our fourth equations of the curve.
There are 3 benefits of discrete least square method to society. First, quality control that can be used to calibrate device and guarantee product quality in manufacturing and quality control. Low measurement error rates contribute to upholding tight standards and cutting waste. Second, environmental monitoring that can be used to analyze environmental data, including information about the climate and pollution levels. It helps with understanding patterns, locating pollution sources, and formulating wise policy choices. And third is optimization. In optimization issues such as minimizing the sum of square discrepancies between observed and forecasted values, least square is used. This is helpful in areas like machine learning, logistics, and operations research.
Next, I'll continue with the sum of the benefits of using the least square method to industry. For the first one, its benefits toward infrastructure planning. Why? Least square techniques are used in civil engineering and urban planning to analyze the data on the transportation, population growth, and other issues. This knowledge aids in resource optimization and better infrastructure design. For the second benefit is machine learning and artificial intelligence. The least square approach is a fundamental method in many machine learning techniques such as linear regressions and neural network training. These technologies are crucial in a variety of applications, including driverless vehicles and recommendation systems.
To conclude, the least square method offers a wide range of applications in a variety of businesses and fields, advancing decision-making, science, economic analysis, and societal progress in general. As a result, society gains from time and resource savings as well as an improvement in the standard of living by reducing errors, improving predictions, and streamlining procedures.